Welcome to the Launchpad, everyone. Today, we're embarking on what I like to call a critical space mission. And our ultimate destination? Absolute, undeniable mastery of the Cambridge Computer Science exam. Now, I want you to think of the 9618 Advanced Syllabus, along with foundational codes like 0417, 0478, 0983, 0984, and 2210 as a highly complex, high-stakes rocket launch. In this kind of environment, there is absolutely zero margin for error. Think about it. Every single calculation, every algorithmic step, and every network protocol analysis you write down has to be perfectly calibrated for a successful launch. So, what's our specific payload for today's mission? We're mastering the notoriously tricky, often misunderstood terrain of static versus dynamic IP addresses. But listen, this isn't just about memorizing a few textbook definitions. No way. This is about executing a flawless exam strategy where you extract the absolute maximum number of marks possible. We're going to completely transform the way you approach past paper questions, and we'll be doing it by using insider insights pulled directly from Cambridge Principal Examiner reports. Trust me, you're going to want to strap in for this one.
Okay, let's quickly go over our flight plan for today's explainer. We'll kick things off with our mission briefing on exam precision. Then, we'll dive into the core principles of IP addresses to really build up our theoretical architecture. After that, we'll implement the procedural framework, followed by some mission-critical examiner warnings straight from the grading room. And finally, we'll put all the pieces together into your final exam strategy.
All right, let's get right into Section 1, Mission Briefing on Exam Precision.
Before we even touch on networking protocols, we really need to talk about your current exam trajectory. Honestly, what is the fundamental difference between a student who barely scrapes by with a passing grade and one who absolutely crushes it to achieve a top-tier score? Well, it all comes down to one word: precision. Let's look at two totally different student profiles to see what I mean. First up, meet Alex. Now, Alex studies incredibly hard, but in the exam hall, Alex completely overloads the answers with raw computer science facts. If a question asks about a static IP, Alex writes this massive, sprawling paragraph detailing that it's a 32-bit number in IPv4, represented in dotted decimal, but never actually applies any of that to the given scenario. There's zero analysis. It's just a giant fact dump. Then, on the other hand, we have Sam. Sam genuinely understands the core concepts, but completely rushes the answers. Sam will see the letters IP and immediately scribble down "dynamic is for phones," completely ignoring the specific command word requirements like evaluate or compare. So, what's the end result for both of them? Both Alex and Sam get their exam papers back absolutely covered in red pen. They failed to secure those top marks because their trajectories are wildly off course. They're lacking analytical depth and precision. But don't worry, because we are going to fix that exact problem today.
Moving on to Section 2, Core Principles of IP Addresses.
To really nail these questions, your knowledge base has to rest on precise definitions and solid causal relationships. Let's break it down. A static IP address is fixed and predictable. I want you to think of it like a permanent space station coordinate. It literally never changes. That makes it highly reliable for things like hosting servers, DNS servers, or even network printers. Basically, anything that devices on a network need to find at the exact same location every single time they look for it. On the flip side, a dynamic IP address is constantly changing, making it incredibly resource efficient. Think of this one like assigning a temporary docking bay to a visiting supply ship. When the ship leaves, that docking bay is instantly freed up for someone else to use. In networking terms, a DHCP server assigns these dynamic IPs from a central pool. The moment a device disconnects, its IP goes right back into that pool. But here is the absolute secret to unlocking top marks. Cambridge examiners consistently highlight that candidates who reference cross-topic connections achieve significantly higher scores. For instance, pointing out how a dynamic IP actually saves a network from the massive problem of IPv4 address exhaustion, or explaining exactly how a static IP interacts with DNS. It's not just about telling the examiner what these things are. It's about proving you understand how they fit into the entire complex network architecture.
And remember, specifically for Syllabus 9618, and honestly for all Cambridge Computer Science exams, the assessment is actively targeting specific cognitive domains. You aren't just being tested on rote knowledge, you're being heavily tested on application and analysis. The examiner wants to know, can you apply the concept of a DHCP pool to a localized hospital network scenario? Can you critically analyze the specific security risks of a static IP? This ability to map abstract theory directly to real-world scenarios is exactly what separates the average, middle-of-the-pack answers from the truly exceptional ones. Now, before we continue on to the practical frameworks, subscribe to our YouTube channel ACE Exams at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
All right, let's jump into Section 3, the procedural framework. This is where we talk technical methodology.
You need to realize that algorithmic thinking requires step-by-step decomposition to earn those absolutely crucial method marks. Listen, examiners will actually award you method marks for your process, even if your final conclusion ends up having a slight flaw. It's all about the working out. The Deconstruct, Solve, Evaluate framework is your absolute non-negotiable blueprint for structuring your answers. Let's walk through it. Step 1. Identify the given info from the prompt. Are they talking about a small office LAN or a massive global WAN? Context is everything. Step 2. Break the problem down into manageable steps. Step 3. Solve systematically, working through the logic. Step 4. Check for reasonableness. Ask yourself, does it actually make sense to manually assign 10,000 mobile phones their own static IP addresses? No, of course it doesn't. And finally, Step 5. Make your recommendations based purely on evidence. This highly structured approach naturally forces you into using the Peel framework. That's point, evidence, explanation, link. Applying this framework instantly transforms a chaotic, rushed answer into a laser-focused, high-scoring response.
Let's deepen this concept a little bit more. Whenever an exam question asks you to evaluate an algorithm or a network protocol choice, you have to bring in evaluative thinking criteria. For example, consider time complexity. How long does it actually take for a DHCP server to lease out a dynamic IP versus the time spent hard-coding a static one manually? Consider space complexity. How much memory is going to be required for the IP routing tables? And you absolutely must consider edge cases. Seriously, what happens to the network when the DHCP pool completely runs out of available addresses? Or what is the performance trade-off of using a static IP that is constantly being targeted by DDoS attacks simply because the address never ever changes? When you evaluate your answers using these exact parameters, you are proving to the examiners that you aren't just memorizing facts. You're showing them that you can analyze complex trade-offs and justify your networking decisions with hard, undeniable evidence.
Okay, challenge time. Let's say we're looking at an IP allocation scenario for a local coffee shop. Which answer correctly applies the Deconstruct, Solve, Evaluate protocol and that crucial Peel paragraph structure? If you're visualizing an answer in your head that simply says, dynamic IPs are cheaper, scratch that right now. That is an instant red pen failure. A perfect Peel paragraph would look more like this. Dynamic IP allocation is optimal for a coffee shop network. The router uses DHCP to lease addresses from a limited pool to customers. Since customers only stay for an hour or so, the lease expires and the IP is immediately reused, entirely preventing address exhaustion. Therefore, this system satisfies the high turnover nature of the coffee shop without requiring any manual configuration from the barista. Do you see the difference there? You have your point, your evidence, your explanation, and your link back to the specific coffee shop scenario. That is exactly how you secure maximum method marks every single time.
Stop scrolling. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to at acetheexams_IGCSE and turn on all notifications so you never miss our weekly exam strategy sessions. Take a moment right now to really lock in what we've covered so far. The gap between a failing grade and top-tier marks isn't just knowing what an IP address actually is, it's having the procedural framework to prove your analytical depth on paper. Every point needs evidence, every explanation needs a tight link back to the scenario. Let's keep moving forward.
This brings us to Section 4, Examiner Warnings. This part is mission critical, so pay close attention.
We are now going to look directly at some of the catastrophic anomalies that are repeatedly highlighted by grading teams in the principal examiner reports. These are the hidden traps that wipe out otherwise excellent, well-prepared students every year. To help you avoid these traps, I've designed a quick memory hack for you, CBG. It stands for Context, Boundaries, Generic. I highly recommend you literally write this down on the top corner of your exam paper the moment you sit at your desk. Always check the context of the question, always test your boundary conditions, and at all costs, avoid generic statements. Let's break down exactly what this looks like in practice.
So based on those examiner reports, here are the top 3 recurring mistakes students make when evaluating static versus dynamic IPs. Mistake number 1, using the wrong formula or algorithm for the context. For instance, imagine suggesting a highly complex static IP subnetting algorithm for a simple 3-device home network. It just shows a complete lack of contextual awareness. Mistake number 2, forgetting boundary conditions and edge cases.
Students will often correctly explain how DHCP assigns IPs, but completely fail to mention what happens at the boundary, like what exactly occurs when the lease time is perfectly up or when the network capacity suddenly hits 100%. Mistake number 3, non-specific answers. This is the ultimate mission failure, guys. Saying something vague like dynamic is safer without actually explaining that a constantly changing IP only makes it slightly harder for persistent targeted tracking, while also acknowledging that true network security relies on robust firewalls, not just dynamic IPs. You have to be specific.
In fact, let me just read this direct quote straight from the Principal Examiner report, because this is a literal warning from Cambridge themselves. The classic mistake is providing generic answers not specific to the question context. Always link every point to the given scenario. It doesn't get clearer than that. If the exam question talks about a multinational banking corporation, your answer absolutely must reference the bank's need for high security, constant 24/7 uptime, and the necessity of static IPs for their primary financial database servers. If you ignore the bank context and just give a standard textbook definition of an IP address, you will get 0 marks for application. 0.
Let's deconstruct a fatal flaw together. Look at this exact sentence a student wrote. Dynamic IP is better because it changes, saving addresses. Take a second and think about why this incredibly generic sentence loses marks, especially based on the examiner commentary we just went over. Look really closely at the wording. Better. Okay, better for what context? A bank? A school? A coffee shop? Because it changes. Right, but what is the actual mechanism behind this change? Saving addresses. What addresses exactly, and why in the world do they need saving in the first place? This sentence scores an absolute 0 for analysis because it lacks context, depth, and precision. The rewritten, top-tier version of this answer should look like this. In the context of a public Wi-Fi network, dynamic IP allocation is more efficient. The DHCP server automatically assigns and reclaims IP addresses as users actively connect and disconnect. This directly prevents IPv4 address exhaustion within the localized private network, whereas static IPs would quickly deplete the available pool and require completely unsustainable manual administration. Boom! That is exactly the level of depth examiners are desperately searching for.
And finally, Section 5, your final exam strategy to reach 100% mark potential.
This is where we bring it all together. This matrix right here is how we combine algorithmic design, rigorous testing, and contextual analysis into one singular, powerful framework. This is essentially your ultimate cheat sheet that guarantees top marks. Let's look at the rows. First up, command word decoding. Your required action is to align strictly to the 9618 syllabus by immediately identifying if the question is asking you to state, describe, explain, or evaluate. The impact of doing this? Absolute precision in your answer. Second row, deconstruct, solve, evaluate. Your action here is to ruthlessly apply the Peel framework for every single extended response. The impact? You secure all those juicy method marks even if your final calculation is a tiny bit off. Third row, contextual link. Your action is to use the CBG memory hack, context boundaries, generic, to avoid those examiner traps. The impact? This is the exact step that pushes you out of the average and into the top-tier grade.
By combining this algorithmic design, the rigorous edge case testing, and those strict contextual links, you achieve something truly incredible on paper. You reach your 100% mark potential. We have seen firsthand that students who actually implement these exact computer science strategies see an average improvement of 2 full grade boundaries. Let that sink in. That is literally the difference between a C and an A, or an A and an A star. But listen to me carefully. This kind of massive transformation doesn't just happen by magic. It only happens if you practice consistently and apply these frameworks over and over to real past papers.
Our mission today is almost fully complete, but your actual journey in that exam hall will be a frantic race against the clock. The frameworks we've broken down today aren't just about getting the right answer. They are fundamentally about efficiency. When you know exactly how to structure a Peel paragraph without second-guessing yourself, you save precious minutes. And that's time you can then allocate to those much harder final section algorithmic questions. Every single second counts when the margin for error is 0. Here's your final reminder. Subscribe to our YouTube channel Ace the Exams, at @acetheexams_IGCS to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCS and click that bell. Don't let another exam pass you by.
Before we officially sign off from this mission, I want you to consider this. What is your biggest vulnerability right now? Are you still struggling with breaking down algorithmic logic, or are you pretty confident in analyzing networking protocols under exam pressure? Identify your weak points today, lock in your coordinates, and prepare for a flawless launch. Drop a comment below with your target grade for computer science and the biggest challenge you're facing. Our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here.
I'll see you all in a next explainer.